Our second video for our first class is covering two sections, section 6.2 and 6.3. And the reason I've grouped these together is because the method for solving each of them is going to be the same. So you'll see up here, I don't know if you can kind of see it. Factoring trinomials when we have no A term, and then factoring trinomials when we have an A term. And so this form here, ax squared plus bx plus c, you should recognize that from when you were learning about polynomials in the last course, Math 1101, or maybe a previous course that you had taken at a different college. This is our standard form for a trinomial. And when we factor a trinomial, we will typically end up with expressions that are exactly the same as when we're factoring by grouping. So just as to recall that, right here we had 4 terms, and when we factored by grouping, we ended up with a binomial times a binomial. Well, the same thing is going to happen here, even though we only have 3 terms. So what we're going to do, and this is exclusively when we have 3 terms, the first thing we do, because we're asked to factor, is we are going to factor out the GCF. That's always what we look for first, regardless of anything else. So again, we ask ourselves, do we have a GCF? And the answer is big fat no. There is no GCF to x squared minus 9x plus 14. So now we want to identify our A, B, and C terms. And those are the A, B, and C terms from up here. A is the leading coefficient. B is the coefficient of our x term. And then C is our constant, which is typically, we want to write it at the end. So here, our A is 1. Our B is -9. And our C is 14. And now the reason we're going to do this is because of the method that we're using. We are going to do A times C. I'm going to write this out for you. So A times C, so that's 1 times 14, which is 14. And then I'm just going to identify B, and you'll see why in a minute. And so what we're actually looking for here, we are looking, that's A. We're looking for numbers that multiply to become 14 and also add to become -9. So to do this, to narrow down the list, I'm going to start by finding all the numbers, or all the pairs of numbers that multiply to become 14. I'm not going to worry about any signs yet, just the numbers themselves. And I like to go in order so that I know that I haven't missed any. So it's always going to start with 1 and 14. Can I divide 14 by 2? Yes, I can. So that's 2 and 7. I can't divide it by 3 or 4 or 5 or 6. And then when I divide it by 7, I just get 7 and 2 again, which I don't need to worry about. Now that we've come up with all of the pairs, now we want to ask ourselves, well, which one of these pairs are going to add up to become -9? Well, the problem is right now, neither of them will add up to become -9. They'll add up to become +9. So in order to make it multiply to become +14 and add to become -9, we're going to make both of our terms negative, because a negative times a negative equals a positive, and a negative plus a negative equals a negative. Now another way to look at this is you can look at your C term and your B term. If your C term is positive, you know that the signs are going to be the same. In this case, 2 negative numbers. And the reason that you know they're negative numbers is because they're always going to match the sign of B, your B term. So which numbers add up to become -9, -2, and -7? And the reason that we're figuring this out is because now we're going to expand our trinomial into a polynomial with 4 terms. And what we're going to expand is we're actually going to expand our middle term. So our first term stays the same, x squared. And then instead of writing -9x, we're going to write -2x minus 7x. And then we're going to drop in our plus 14. So again, we're rewriting our original trinomial now with 4 terms, but we're expanding it. So we're splitting up, we're expanding that middle term to be the minus 2 minus 7, minus 2x minus 7x. And now that we have 4 terms, we do what we learned in the last section, and we factor by grouping. So we group our first 2 terms together, we group our last 2 terms together. We have to remember that we don't want a negative in the middle, so we're going to push that negative to the 7x, and we're going to put a plus in the middle there. Then we find our GCF of our first group and our GCF of our second group. So our GCF of our first group is x, and we're left with x minus 2. Bring down our plus from the center there. Our GCF of our second group, remember, because the leading term is negative, we're going to bring a negative out with that. And then we have a 7 and a 14, which we can divide both by 7. So that's our GCF there. And that leaves us with x, and then positive 14 divided by negative 7 gives us negative 2. Like the previous section, we have 2 terms, and we ask ourselves, what do they have in common? They each have the x minus 2, so we factor that out up front, x minus 2, and we're left with x minus 7. And again, we can check this by using our FOIL method to multiply this together and make sure that we get right back up to where we started, x squared minus 9x plus 14. So this method of factoring will work whenever you have a trinomial and your trinomial is actually factorable. So let's try part B. So in part B, we have 4x squared plus 28x plus 48. Again, the first thing we look for is a GCF. So do we have a GCF? Right, that's the first thing. Do we have a GCF? Yes, we do. What is that GCF here? The GCF is 4. We can divide everything by 4. Oh, that's so ugly. Let's do that again. GCF equals 4. There we go. Now, remember, just like in the last section, if we constantly keep the 4 with us in every single step, it's going to be very cumbersome. So we're going to have a factor line down here, and I'm just going to drop my 4 right in there. And that way, we can just figure out what we have left over after factoring out our GCF of 4. That would be x squared plus 7x plus 12. And now we do exactly what we did before. We identify our a, b, and c values. A equals 1, b equals 7, and c equals 12. We have our a times c, which is 12, and our b, which is 7. And we're looking at what numbers are going to multiply to become 12 and add to become 7. Now, even though it might be tempting, and you want to make sure that you are identifying all of the numbers, all of the pairs of numbers that you could possibly have. And I'll explain why. I'll show you why in a minute. So we have 1 and 12, 2 and 6, 3 and 4. And then if we keep going, we would just have 4 and 3, 6 and 2, 1 and 12, and so that would be it. And then what numbers are going to multiply to become positive 12 and add to become positive 7? And that's going to be 3 and 4. Oops. Now I just want to remind you about the signs, right? When we take a look at our sign of C, it's positive here, right there. It's positive, so that means that our signs are going to be the same, and they're going to match the sign of B, so they're both going to be positive. We can use this to expand our original expression, and we're expanding our middle term. So we have x squared plus 3x plus 4x plus 12. Now, the nice thing about this is you don't even have to put it in this order. You don't have to put plus 3x plus 4x. You could put plus 4x and then plus 3x, and that's completely up to you. Either way you do it, you're still going to get it correct. And that is in any case that we're doing this type of factoring. It's a nice thing about it. So again, we go ahead and group the first two terms and the last two terms. We already have a plus in the middle, so there's nothing to move or push or worry about there. Our GCF of our first term is x, and that leaves us with x plus 3. The GCF of the second term is 4, which also leaves us with x plus 3. Our GCF of our two terms here is x plus 3, and we are left with x plus 4, which we're going to take and finally put on our factor line. X plus 3 and x plus 4. And so that's our final answer. Moving on, we have 2x squared plus 13x plus 15. So again, we ask ourselves, do we have a greatest common factor? Is there a GCF? And the answer is no. So then we move on to identifying A, B, and C. A is 2, B is 13, and C is 15. Again, we work with A times C, which is 2 times 15, so that would be 30. Just identify B one more time. And we want to look for numbers, again, that multiply to become 30 and add to become 13. So I'm going to start by listing all my pairs that multiply to become 30. 1 and 30, 2 and 15, 3 and 10. I can't divide it by 4. I can divide it by 5, 5 and 6, and that's the end of it. Our signs, again, we have a positive C value, so our signs are going to be the same, and they're both going to be positive. So we don't have to worry about putting any signs in there. And now, which pairs of numbers will add up to become 13? And that would be 3 plus 10. Now, the reason I always say to write all of the pairs out here is because in another situation, like if this were a negative 30 instead, you could have positive 15 and a negative 2. That could also add up to become 13. So you want to give yourself as many options as possible so that you can, make sure you can see everything possible. So now that we have our two terms, we will expand our expression, our original expression. Remember, the first term stays the same, 2x squared. And then the middle term, 13x, is going to change into the plus 3x and plus 10x. And it doesn't matter what order we go. And to show you that, I'm just going to do the plus 10x first here, and then plus 3x, and then finally drop down my plus 15. So we have 4 terms, so we're back to factoring by grouping. We have a plus in the middle, which is what we're supposed to have when we factor by grouping. What's the GCF of our first term? That would be 2x. We're left with x plus 5. What's the GCF of our second term? That would be 3. And again, we're left with x plus 5. So our GCF of both of these two terms is going to be x plus 5. And we have 2x plus 3 left over. And so that's going to be our factored form. And again, remember, you can use the FOIL method to multiply this out and check. Now, I highly recommend checking your work. It doesn't necessarily have to be on a sheet of paper, but it could be, in your head or just kind of by looking at it. But I really recommend that. So lastly, we have part D. We have 12y squared minus 5y minus 3. So again, we're factoring. We ask ourselves, do we have a greatest common factor? And the answer is no. So once we can see that, then we identify our A, B, and C values. A is 12, B is negative 5, and C is negative 3. So we do our A times C, which is going to be 12 times negative 3, which is negative 36. Our B again is negative 5. And we need to find all of our factors that multiply to become negative 36 and add to become 5. So now when we find these pairs, even though this is a negative 36 now, we're still just going to work on the factors of 36, so the pairs of 36. And then we're going to work with the signs later. So we have 1 and 36.